Now this is Movable Bridge, Inventors, Part 4. Now I'm looking at trunnion, Chicago types, and simple trunnion types. The Chicago type trunnion basketball bridge was developed by the City of Chicago Engineering Department and with John Erickson and um, and all others like Thomas Pelleff and all that, right? Um, the trusses are supported on trunnions and aligned with the lower chord placed in the short distance back from the center of gravity of the span. The counterweights are rigid, attached to the end of the shore arm, and the pit is provided in the pier from the reception when the bridge is open. The leaf is operated by pinions and cylindrical rack attached at the end of the short arm. Elastic bumpers are provided to absorb the shock in the opening and closing of the span. A worm gear brake is also supplied to check any downward in motion at the leaf. It should occasion required. For a double leaf bridge, essential locks are employed, but no real locks are needed at the center of gravity is ahead of the pivot. Now this is the first trunnion basketball bridge on Cortlandt Street, and it's um, uh, located in Chicago, Illinois. So, see, that's what it's talking about right there. Right? Simple train basketball bridge are mostly of the double leaf trunnion for highway traffic. They open with racks and curve with pinions and shafts with the machinery that pivots around the rack and pinion that balance both leaf and counterweight balance system. Double trunnion bridges are the most common of the true simple trunnion type built in 1894 when the Tower Bridge, which was a double section, crossed the Thames River in London, England, and widely known as drawbridges worldwide. Most double basketball bridges are the plate and deck girder types and quite popular of the truss type. There are still constantly new bridge applications by different bridge companies, like right now, like today, by the designers that work with the engineering firms. There are some single leaf trunnion basketballs that use a narrow channel, and the double leaf use the two channels for each leaf that meets at the center when the leaves lower in a closed position. Some single and double leaf basketball bridges are twinned by having two parallel spans across the navigation channel. Yep. Some bridges are connected so that the pair of leaves on one side of the navigation channel acts as one, and some are left independently so that each leaf acts separately. Simple train basketball bridges consist of anterior rigid displaceable structure supporting on the horizontal pivot. Sometimes the pivot shaft is stationary and the bridge pivots around it. Mentioned earlier, the pivot shaft is more often fixed to the basketball span. in which the two train arrangements and the ends of the trains are supported in the sliding or and fraction bearings. And so, an example of a twin parallel doubly basketball bridge, train basketball bridge is a First Street South Avenue bridge located in Seattle, Washington. So, and over the Duwamish River. So, Waddell, John Alexander Lloyd Waddell is a chief engineer in designing vertical lift bridges. His first design was a lift bridge at South Hampton Street in Chicago, Illinois, crossing the South Branch Chicago River in 1893. Now this is his first vertical lift bridge constructed. The Hampton Street lift bridge across the South Branch Chicago River at Chicago, Illinois is his first bridge built and it's now replaced. So, yeah, so this is his first bridge. Waddell built a reputation as one of the 20th century best known and highly respected bridge builders. Then prior to forming his own firm of engineering and design of the bridges, then he taught engineering in Japan. Waddell was a prolific bridge designer and with more than 1,000 lift bridges in his credit in the United States, in America, Canada, as well as Mexico, Russia, China, Japan, and New Zealand. His lift bridge spans the Mississippi, Missouri, Nigeria, and the Colorado rivers. And Waddell specializes in modern vertical lift bridges, and his partner is John Lowell Harrington, who works with Waddell in developing lift bridges. These lift spans are mostly of the span drive because the machinery is mounted on the span with the operating rope drums. Each drum are mechanically with the four the that pulls and plays the pairs of ropes as the bridge opens and closes. The ropes of each drum connects to the corresponding corner of the moving span. Excuse me. One pair extending to the fixed connection at the top of the tower are the uphaul ropes, and the pair extensions of the fixed to the tower base of the downhaul ropes. Most lift bridges are the span drive or Waddell type have counterweight sheaves. There are cast or welded subjected real high loading. Their proper design and high quality fabrications are external for the long while. Some lift bridges variants has auxiliary counterweight. The diagonal ropes extending from the center of the lift span to the towers, reaching down and connected to the weights hanging alongside the tower legs. Those ropes pull up on the span when down and when it's down and down and when it's up. Compensating for the weight of the ropes and other varying isolated counterweights are diagonal ropes extending from the mast, reaching up from the center of the span to the tower tops, reaching down and connect the weight hanging alongside the tower legs. The ropes pull up on the span when it's down and down when it's up. So some lift bridges of the Weddle type have balance chains made with cast iron heavy links, which were once commonly used to compensate for the counterweight or operated ropes that passes over the sheaves. The one end of each chain hangs from the bottom of the counterweight and the other attached to the fixed point of the tower. As the span lifts, the counterweight lowers and the weight of the chain passes from the counterweight to the tower. As the span lowers, the weight of the chain is transferred back to the counterweight. Another variant type vertical lift bridge is a tower span. Note, not with a type. And sometimes there are some with other types though. This lift span has no machinery on the lift span, but mounted on each tower with counterweight ropes with sheaves, very similar to the other lift bridges. The counterweight ropes are the main structural supports to the counterweight attachment. Some lift bridges also has balance chains mentioned earlier, but also has tower tied together by means of a strut. By reaching across between tower tops, they are related to the drive system. An example, Willer Street or Willer Avenue lift bridge in Cleveland, Ohio. Yeah, this is the um, Willer Avenue Whiskey Island vertical lift bridge with ballast chains and across the Cuyahoga River in Cleveland, Ohio. They are less popular than other lift bridges. Strauss and Raw lift bridges. Joseph Strauss, who specializes in vascular bridges, also developed vertical and direct lift bridges, lift spans. An example is the Strauss lift bridge in Hardin, Illinois, crossing the Illinois River. See, this is Joe Page Strauss vertical lift bridge right here, right? And it crosses the Illinois River, located in Hardin, Illinois. It's a Strauss type. The lift span is operated by racks and pinions instead of ropes. A gear rack is mounted on it vertically with the axis of the teeth parallel to the bridge axis. Motor and gear reductions located in the house atop the center of the span drives a long shaft reaching to the ends of the lift span. At each end of the lift span, additional gear reduction drives the rack pinion, which is held by a mesh with the vertical rack that mounts on each tower, and expansion end of the bridge with extra wide teeth and provide so the dimension maintains the contraction of the lift span. A direct lift bridge, Strauss type, those are odd separated variants in eventual direct lift designs that uses counterweight arrangement of a heel trunnion bascles to balance the lift span. Each tower supports the counterweight on trusses frame links to each of the lift span. There are no counterweight ropes or sheaves, but provided a pivot counterweight plan. The rack and pinion machinery is used to operate the lift span. Few of them types of bridges were built. The counterweight and truss rise or rollers on the track and moves towards and away from the lift span as it raises and lowers. One Strauss direct lift bridge is still in use for the Burlington Northern Santa Fe Railroad located between Tacoma and Steilacoom, Washington, crossing the Chambers Creek. Now this is an example of the Strauss direct lift bridge, Burlington Northern Santa Fe Railroad direct lift bridge. Direct lift bridge crossed the Chambers Creek between Tacoma and Steilacoom, Washington is a Strauss type who specializes in bascule bridges. So, yeah, so this is it. A rod type has one formerly in LaSalle, Illinois, for the Chicago, Burlington, and Quincy Railroad over the Illinois River, constructed by the Strobel Steel Construction Company. Now that's a raw direct lift bridge. Chicago, Burlington, and Quincy Railroad direct lift bridge across the Illinois River and LaSalle, Illinois replaced. The bridge is a raw type constructed by the Strobel Steel Construction Company. Whipple. Square Whipple designed a few of the 15 operating processors that lift spans in the western upstate New York area in 1870s, crossing the Erie Canal. This lift span has an overhead rigid truss structure supported on towers with the rollway deck suspended from the tension rods. The deck was left to clear the canal, and the bridges were manually operated by tread wheels mounted on the overhead truss. These lift spans are small, 60 foot long and 18 feet wide. The lift portions of the lift span were counterweighted like the modern vertical lift bridges, but actually operation of the lift span was accomplished by falling weights, which were lifted back into position by a tread wheel. Each bridge is lifted and counterbalanced by mechanisms that are under the rollways, which push the bridge up less than 10 feet to provide clearance over the canal. Now this is a Whipple type vertical lift bridge. Ingersoll Street lift bridge across the Erie Canal at Ebony, New York. So, and yeah. A towerless lift bridge is not Whipple type. Yeah. It's not the Whipple type. Similar to the Erie Canal bridges crossing the Milwaukee River at Milwaukee, Wisconsin. These lift bridges are non-hydraulic examples of the similar drive system. Yep, so yeah, the Wells Street lift bridge across the Milwaukee River in Milwaukee, Wisconsin. So swing bridges center and rim bearings. Swing bridges operate by pivoting or swinging aside for ship and vessel traffic. A few swing bridge span bridges were designed by George Morrison and other swing bridge constructed by bridge construction companies and railroad firms. Swing bridges were popular since the 1800s. but some were replaced with bascule and lift bridges. There are two types of swing bridges, center bearing and rim bearing. The center bearing swing bridge is loading girder transfer the dead load of weight of the swing span to the center pivot center bearing. 3 points of the three truss and center. Some swing bridges have balanced wheels and end wedges that require the stabilization and not live support. The balanced wheels is based around the circular track. Rim bearing swing bridges have rollers around the rim with rack teeth to open and close the span. The rack has a pinion and a track with taper rollers built in. The load elevated around the edge of the primary pier. Rim bearing with 4 point each end side of the drum or the center. Some swing bridges have combined rim and center bearing with the part of the load carry a center bearing connected to the rim bearing by vertical struts. These struts are presented at one pure rim bearing that serves only to maintain the position of the rim girder on a rim girder about the bridge center. On the combined bearing bridge, the struts are primarily load carrying members. The trusses and main girders are directly on them, while the outer of the strut is supported by the rim girders and inner end is support on the center pivot. The distribution of load between the rim and the center bearing varies, but most bridges of this type are major part of the load carry of the rim. With bobtail swing bridges, there are some examples of asymmetrical swing bridges with truss and girder types on all swing span bridges. Some short, lighted weight bobtail swing bridges are not calibrated and at their long arms when in closed position, but act as a simple span with very short cantilever span extension from the other side of the pivot point, the reaching beyond the extremity of the pivot pier. So, some bobtail swing bridges have counterbalanced weights at the end of the span. An example of a counterweighted swing span, a railroad swing bridge in Chicago, Illinois, the Chicago River Canal. Now this is a Cherry Avenue, former Chicago, Milwaukee, and St. Paul Railroad swing bridge with a counterweight overhead across the Chicago River, North Branch Canal in Chicago, Illinois, and one in St. Paul, Minnesota, crossing the Mississippi River. See, now this is a two-wing counterweight, which is made of concrete. The Union Pacific Railroad swing bridge, a counterweighted bobtail type across the Mississippi River at St. Paul, Minnesota. Yeah. Another Barrington type of swing span is a shear pole type that's pivoted at one end of the bobtail type. The free end of the shear pole swing span is supported by tension rods or cables reaching down from an overhead structure. This span is usually consists of a derrick type post forming of an A-frame around and above the pivot end of the bridge, a frame guide by the cables stretching to the rear inside of the frame. The operation of the bridge may be of the cable drums arrangement that pulls the bridge open and closed, and some bridges have racks and pins, machinery drives similar to the swing span. The simple span with long, simple sliding into the closed position until the supporting masonry plates or strike plates. One shear post swing bridge for rail traffic is was in operation, but it's gone because of a train collapse. So now, this is an example of a shear post swing bridge. Conway Railroad frame swing bridge of a few shear post type across the Meeting Creek at Paulsboro, New Jersey, collapsed into the creek of a train wreck. So, and now, um, now this is the end of the movable bridge engineer and inventor. So I hope you enjoyed it, and I'm gonna put more bridges up for my drawings and everything. So this is what's going on. So all right, so.